Hey, what up, guys? Let's go over this quick little inverse function practice. It's going to be due this Sunday. So it says find the inverse of each function. So just remember for your own sake of remembering what this means, the inverse has a couple different ways of talking about it. This is the complete undoing function. So it goes backwards. Some people like to use the word opposite, but opposites aren't really right. Opposite's more of the word negative. The complete undoing or the backwards. And remember, another way of thinking about it is all inputs become outputs and vice versa. So all of your x's become y's and your y's become x's. And that's what you're thinking about here. However, while you're doing that, there are a few ways of doing these questions. So because it is the complete undoing or the going backwards, I'm going to do number one using the English version of this idea. And then on number two, I'm going to go, actually, like the odd ones, I'm going to do the English version, and the 2 and 4, I'll do like the algebraic version. I'm not going to do the table version or the graphing version because I don't think those are best for video. Anyways, let's get going. So the idea here is what is happening to n. That n right there is getting multiplied by 8. And then after you multiply it by 8, it's going to be adding by 5. So this is kind of what happens first, and this is what happens second. So you're going to be doing this, undoing it completely. So in other words, what happens second, you're going to undo that. So now what happens first on the backwards version is going to be subtracting 5. You're undoing the adding 5. And then what happens second is you're dividing by 8. You're undoing that multiplying by 8. So to use the correct notation for your final answer, I'm going to write my final answers in purple here for this question. We would say G inverse of n, and that is not a -1 exponent, but instead it means inverse. So G inverse of n is equal to n minus 5, so we're subtracting 5 from n first, and then we are dividing by 8. And there you go. However, for these questions, you are also able to do them what is called algebraically. So instead of using the English, you're able to use algebra instead. Some people do prefer this version. And honestly, questions like number 4, it's actually easier just to do it algebraically than it is to do it using the English. So let's check this out. So the first thing you're going to do if you're doing the algebraic version is rewrite this as a y for your output. You're going to switch the x's or in the y's, or in this case, you're switching the n's in the y's. And now we're going to solve for y. So we're going to start by taking that -7 and moving it to the other side, and it becomes a +7 on the left. I'm running out of room here, so I'm going to move up here. After we have the +7 on the left, we're going to divide both sides by -2. And then we're just going to rewrite using that correct notation. Again, I'm writing it in purple. It happens to be the letter G with the inverse again. Is n plus 7 divided by -2. There you go. Let's check out number 3. So again, I'm going to be doing number 3 using the English method. So what is happening to x here? So for x, you're getting multiplied by 7, and then you're adding 12, and then you're dividing by 4. So the complete undoing of that is going to be multiplying by 4, subtracting 12, and dividing by 7. So using the correct notation, this time it is an f and an inverse. F inverse of x is going to be x times 4 minus 12, and then divided by 7. It's probably more natural to write it like this, like where you write 4x. So you don't necessarily have to do that, but I do recommend it just for your own sake clarity. All right. Number 4, so again, you could do this English method, but the English method is really hard because you're multiplying by 5, then you're dividing by 2, and then you're adding 19 over 2. And instead of adding 19 over 2, you're going to subtract 19 over 2. I would rather just do it the algebra way. So doing this guy the algebra way here, we have y is equal to 5 over 2x plus 19 over 2. Switch the x's and the y's, because that's the idea. All your x's become y's, all your y's become x's. we're going to multiply every single term by 2. So multiply by 2, multiply by 2, multiply by 2. When you do that, you're going to get 2x. The 2's cancel here, and the 2's cancel there. Nice. Now we don't have any more fractions. So again, we multiplied everything by 2. Now we need to continue solving for y. We're going to move the 19 to the other side. And then divide both sides by 5. And let's use that correct notation. So our correct notation for this problem, f inverse of x is 2x minus 19 over 5. Beautiful. All right. So number 5 here, it says state that if the given functions are inverses by using the formal definition. So the formal definition of an inverse says that f of g of x are inverses if and only if f of g of x equals g of f of x equal to x. We got to show that these are true. And you have to say it if they are. So some of these might not be. In fact, 2 of them aren't. So number 5, I kind of gave it to you as what I would call a freebie. It's supposed to be very, very simple to show that these are definitely inverses. So f of h of x, we're going to do that first. So we're going to rewrite the h right there with the f inside. So x plus 1 there, because that h of x became x plus 1. Now f of x plus 1, that x right here is going to become x plus 1. So now we have x plus 1 minus 1. Plus 1 minus 1 is just x. Check mark. We've done the first one. Now we have to do the second one here, g of f of x. So that means we have to go the other way around. H of f of x. H of f of x, well, that guy is going to be equal to h of x minus 1. And that's going to be equal to x minus 1. You're replacing that x right there with this x minus 1. So add 1 at the end. And that is also equal to x. Check mark. Easy peasy. Going on to the next one, same exact idea. We have to show that each one of these is the inverse of the other. So if I were to do that, let's do f of h of x first. F of x plus 4 is what that's going to be. F of x plus 4, that means that this right here, that x is going to come in x plus 4. And no matter what we do with simplifying this, there's no way it's going to end up being an x, because I'm still going to have to divide by 4 at the end. Like, that's going to be like a negative 4, and then like that's like a positive 15. 15 divided by 4 is not 1. You know, this is not going to work out. So this, after you get to this step, you can just have a big no. Definitely not inverses of each other. Similar things are going to happen on number 7 if I were to start with f of g of x first. F of negative 2 over 5x minus 2 over 5. Which means that this right there, that x 2 times negative 2 over 5x minus 2 over 5 minus 3. And no matter what you do, again, multiplying this out, multiplying these by 2, you're going to get like a negative 4 over 5, negative 4 over 5, minus 3. It's going to be like negative 19. It's definitely not going back to x. So again, you just have this big no. Let's check out number 8. So if we did 8, we're going to do the same exact thing. We're going to do f of g of x first. F of g of x means that we're doing f of 5 plus 1 half x. 5 plus 1 half x is going to be slotted into where this x is right there. So it's going to be 2 times 5 plus 1 half x minus 10. Now this time, you might be noticing things are going to start canceling out, because 2 times 5 is 10, and then minus 10. Let's check this out. Distribute it out, we get 10 plus 2 times 1 half x minus 10. 10 minus 10 cancels. 2 and 2 cancel. We just get x by itself. Same exact thing must be done with g of f of x as well. G of 2x minus 10, 5 plus 1 half of 2x minus 10. Distribute that 1 half. Just like we saw in the previous question, 1/2 times 2 here is going to cancel out, so we just get x by itself. 1/2 times -10 is -5, and sure enough, 5 and the -5 cancel. We get x by itself. Yes. Forgot to write the word yes over here in the spot. Anyways, we're all done. Have a wonderful rest of your day. Peace out, guys. See ya.